Welcome to Your Math Explained, where we make math simple and clear. My name is Angela, and in this video, we'll break down expansions and compressions of functions. You'll learn how to create new graphs from an equation, as well as stretching existing graphs. So let's get started with a Desmos demonstration. Here we have our function f of x. And notice how our a and b values are 1 right now. So if I turn on this graph, it is just equal to f of x, so it overlays the original graph completely. Let's go ahead and play around with our a value. So if we were to change it to 2, notice how the new graph is now a vertical expansion of the original graph by a factor of 2. So this line here used to be at a y value of 2, it is now at a y value of 4. And similarly, our lowest point used to be at a y value of -2, it is now at a value of -4. So all the y values doubled. But one important thing to note is that the 0 stayed at 0. So it is a stretch with respect to the x-axis. Next, let's take a look at what happens when our a is between 0 and 1. So if we want to have a value of 0.5, what it is it's going to be a vertical compression by a factor of 2. So our value here that used to be at 2 is now at 1. And similarly, this -2 here has now been compressed to -1. So let's drag the slider around, and we can see that 1 is where you get the original graph back. And that as we increase it, it gets taller and taller. And if we were to make this number smaller until it's less than 1, it is going to get shorter and shorter, and it's going to get more and more compressed towards the center, towards the x-axis, until it hits 0. And then what happens when it goes negative is it actually flips over the x-axis. So you might remember this from our reflections chapter. If it's equal to -1, that's just negative f of x. So therefore, it flips over the x-axis. But if we make this number more negative, it's going to do that flip, and it's going to stretch. So let's go ahead and return this back to 1 and take a look at what happens when we change our b value. So for b, it is the value beside x that's inside the function. So if we change our b value to 2, you'll notice that it actually does the opposite of what you think it might do. Instead of expanding it by a factor of 2, it is actually being compressed by a factor of 2. You can't actually see where this point ends, but you can see if I were to drag it for the x value, it ends at 1.5, whereas in the original blue graph, it ends at 3. And similarly, on the left-hand side, our furthest x value used to be -3, and now it is at -1.5. So this b is equal to 2 actually compressed our graph horizontally by a factor of 2. Now if we change this b value to 0.5, what it does is it expands the graph horizontally by a factor of 2. So that means originally we ended at x is equal to 3. Now the new graph ends at 6. And then on the left-hand side, instead of it ending at -3, it now ends at -6. And just like what happens with the a value, if we make our b value negative, it is going to be a flip over the y-axis. So then if it gets more negative, it actually compresses more and more after the flip. And then if we have a negative value that is between 0 and -1, it stretches the graph as well as flipping it. So let's go ahead and generalize what we have just seen. So our function y is equal to a times f of b times x. We're going to have the following transformations. So the a that is in front of the f is going to be a vertical stretch by a. And when we say stretch, that includes both expansions and compressions. So if a is greater than 1, then it's going to be an expansion by a factor of a. And if a is a value that is between 0 and 1, it is going to be a compression or a vertical compression by a factor of 1 over a. So meaning if a is 1/2, it is a vertical compression by a factor of 2. And finally, if a is negative, it is going to be a reflection over the x-axis. Now, not only is it a reflection over the x-axis, if a was, let's say, -2, then you're going to have an expansion and a reflection. Next, let's take a look at b. b is the value that is inside the function in front of x. And what it does is it is a horizontal stretch by a factor of 1 over b. So the opposite of what happens with a. So meaning if b is greater than 1, it is going to be a horizontal compression by a factor of b. So for example, if b is 2, we're actually compressing it by a factor of 2. And if b is between 0 and 1, this is a horizontal expansion by a factor of 1 over b. So again, if b is, let's say, 1/2, it is going to be an expansion of 2. And now if we have b is less than 0, it is going to be a reflection over the y-axis. And similarly to what happens with a, you could have expansion and compression in addition to the reflection. So now let's go ahead and apply that knowledge to this problem here. For this question, we're given the graph f of x. And what we want to do is we want to sketch 4 different types of compressions and expansion. So we're going to do the vertical expansions and compressions on the first graph, and then we're going to do the horizontal ones on the second graph. So the first one is going to be 2 times f of x. So what that means is it's going to be a vertical expansion by a factor of 2. So the easiest thing to do is to label these points. So this one is 3, 3. This point here is 0, 2. And then this point here is -3, -2. So a vertical expansion by a factor of 2 means that all the y values are going to double. So our 3, 3 is now going to become 3, 6. Our 0, 2 is going to become 0, 4. And then our -3, -2 is going to become -3, -4. So the new graph is going to look like this. So this one here is our 2 times f of x. Let's draw our next graph in another color. So we want to do 1/2 of f of x. So what this means, it is going to be a compression vertically by a factor of 2. So that means our 3, 3 is going to become 3, 3 over 2. And then our 0, 2 is going to become 0, 1. And then our -3, -2 is going to become -3, -1. So this is what we're going to end up with. And you can see that this is just the original graph compressed by a factor of 2 vertically. Now let's move on to the horizontal transformations. So the first one is f of 3x. So what that's going to do is it's going to be a horizontal compression by a factor of 3. So let's go ahead and relabel these points. We have 3, 3. We have 0, 2. And then we have -3, -2. So what this means is the point 3, 3 is going to become 1, 3. The point 0, 2 is still going to be 0, 2 because 0 divided by 3 is still 0. And then the point -3, -2 is going to be -1, -2. So therefore, our graph is going to look like this. So this is our f of 3x. And then the last one, that is going to be f of 1/2 times x. So that is going to be a horizontal expansion by a factor of 2, meaning all the x values are going to double. So the 3 is now going to become 6 Again, the 0 is still going to be 0 And then the -3 comma -2 is going to be -6 comma -2. So that means this graph is going to look like this. So let's label that. That is going to be our f of 1/2 x. So notice how each of those transformations, when we're dealing with horizontal expansion and compression, it does not change the y value at all. And when we're dealing with the vertical expansion and compression, it does not change the x value at all. One additional thing that I want to point out is there are a couple of different ways to say this. We say expansion and compression, but we can also say stretch. So when we're talking about expansion and compression, the number that is attached is always going to be greater than 1. So for example, if we're talking about 2fx, that is going to be an expansion by a factor of 2. And if we're talking about 1/2 fx, we say that is a compression by a factor of 2. And that is because expansion and compression already has the direction built in. But if we're talking about stretch, it doesn't have a direction built in. So again, if we are talking about 2 times f of x, we would say that is a stretch by a factor of 2. But if we're talking about 1/2 times f of x, we would say that is a stretch of 1/2. So now let's go ahead and do a recap of everything that we have just learned. So the b value that is inside the function, what it does is it performs a horizontal stretch. And that's going to be either an expansion or a compression. But remember, it is the opposite. And the a value is a value that is outside of the function, in front of f of x. And what that does is it performs a vertical stretch. And this one is the same effect. So if a is greater than 1, it is going to be an expansion. And if a is between 0 and 1, it is going to be a compression. And remember, if any of them is negative, it's also going to result in a reflection. So now, with that information, can you find out what is the transformation that have occurred if we have our f of x and we're applying this transformation? Leave your answer in the comments below and let us know if you'd like to see more content on expansion and compression in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.